Good day, ladies and gentlemen. You are welcome to another tutorial on chemistry. And today's topic is oxidation number and Iupac nomenclature. So we are going to be learning how to calculate the oxidation number of an element in a compound, and also learning how to name the compound too. So Iupac nomenclature. Iupac simply means International Union of Pure and Applied Chemistry. So they are here to standardize a lot of things on chemistry, both on nomenclature and the rest. So we have our question number 1. Calculate the oxidation number of sulfur in H2SO4. Then II give the Iupac nomenclature. Okay, so calculate the oxidation number of sulfur in H2SO4. Number 2, give the II, that's give the Iupac nomenclature. So we are going to do that now. Solution. For you to be able to calculate the oxidation number of an element in a compound, you need to know the individual oxidation number of those elements. Okay, so we have here H2SO4. That means we need to know the oxidation number of hydrogen. And what is the oxidation number of hydrogen? It's what? 1. How do I know that the oxidation number of hydrogen is 1? Oxidation number of hydrogen is 1 in this kind of compound because let me just show you. What is the atomic number of hydrogen? Just 1, right? So we have 1. So since we have 1, it is what? Plus 1. So the oxidation number of hydrogen is what? Plus 1. So we are written 1. Then we have 2 at the front of what? Hydrogen. So we multiply it by that 2 times what? 2 plus. We are looking for what? We are looking for sulfur. So we just write S, sulfur. Now we have oxygen. We are left with oxygen. You ask yourself, what is the oxidation number of oxygen? It's -2. How do I know it's -2? Watch me. What is the atomic number of oxygen? It's 8. Hydrogen, helium, valuable carbon, nitrogen, oxygen, 8. All right. So I will now put this 8 electron in a shell. So remember, the first shell can only take 2. 1, 2. The second shell can take up to 8. But when we put 2, 2 minus 8 remaining was 6. So we have 1, 2, 3, 4, 5, 6. So we are left with 1, 2, 3, 4, 5, 6. If we have 6 electrons, it won't be plus 6. No, it will be. You ask yourself, how many electrons does this oxygen needs to complete 8? How many? 2, right? Yeah, you got it correct, 2. So since it needs 2 to complete 8, that means it's accepting 2 electrons. So it will not be what? -2. It will not be -2 because it will accept 2 electrons. So let me just give you a total rundown. If you have 1 valence electron at the outermost shell, it is +1. If you have 2 valence electron, it's +2. If you have 3 valence electron, it's what? +3. So let's go to 5. If you have, because 4 has variable oxidation number, 4 has +2 and +4. So let's go to 5. If it has 5 valence electron, it's what? It's -3. If it has 6 valence electron, just like oxygen, it is -2. If it has 7 valence electron, it's what? -1. So you can see oxygen has 6 valence electron at the outermost shell, so that is -2. So here, oxygen is what? -2. There is 4 at the front of oxygen, so times 4. We equal it to 0. Do you know why we equal it to 0? We equal it to 0 because H2SO4 is a neutral compound. It's a neutral compound. What do I mean by neutral compound? A neutral compound is a compound that has no charge. It has no charge. you can see there's no charge here. There's nothing like minus. For example, if I write something like NO3 minus, this is not a neutral compound. It has charge because you can see minus. This one is -1. It has what? Charge. Or if I write SO4 minus, it is not a neutral compound because it has charge, which is what? -2. So any compound that has charge, you call it to what? To be charged. All right. So since this is a neutral atom, we call it to what? 0. So let's calculate. 1 times 2 give us 2 plus S minus 2 times 4. 2 times 4 give us 8 equals to what? 0. What do we do? Collect like times. So 2, 8 means minus 8 plus S. Remember, this is S, not 5. S. S, okay? Equals to what? 0. 2 minus 8 will give you what? Minus 6 plus S equals to what? 0. Collect like times. Because minus 6 cannot be added to S. Numbers cannot be added to alphabet. So collect like times. It means this 0. So cross over, S equals to 0. When minus is crossing over the equal to side, turn to what? Plus. So plus 6. 0 plus 6, S equals to what? 6. Our S is equals to 6. So we have answered question number 1. The oxidation number of sulfur in H2SO4 is what? Plus 6. Now, to answer the II, they said give the Iupac nomenclature. For II, the Iupac nomenclature is, watch this. 4 is tetra, O is oxygen, so tetraoxosulfate. So we do not call it sulfur. S is sulfur, but we don't call it sulfur since it is with an element, more especially an oxygen. So we call it tetraoxosulfate. So 4 means tetra, 3 means tri, so tetraoxosulfate. So tetraoxosulfate. Sulfate what? Sulfate 6. Okay, so tetraoxosulfate. Sulfate what? Because sulfate what? 6. The oxidation number, because the oxidation number of sulfur here is 6. Tetraoxosulfate 6. And we write it with the Roman numeral, sulfate 6 acid. Yes, sulfate 6 acid. Why did you call it acid? Because of this hydrogen. So we didn't include this hydrogen in our Iupac nomenclature because it's an acid. If it was another element, we would have included it in our Iupac nomenclature. Okay, so let's go to another question. So here we are asked to calculate the oxidation number of sulfur in Al2SO4 bracket 3 and to give the Iupac nomenclature. Very simple. Remember, for us to calculate the oxidation number, we need to know the individual oxidation number of the elements in this compound. So let's go. Solution. What is the oxidation number of aluminium? What is the oxidation number of aluminium? So let's go. If you remember what I taught in example number 1, what is the atomic number? You ask yourself, what is the atomic number of aluminium? So atomic number of aluminium should give us 13. Yeah, I hope you already know how to recite your first 20 elements, or you also have your periodic table, but at least you should know how to recite your first 20 elements or even first 30. So let's see whether we're correct. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, 10. Sodium, magnesium, aluminum, 13. So since it's 13, we put 13. Remember, the first shell can carry on with 2. So 1, 2. Remain the what? 13 minus 2, that's one. So remember, so the second shell can carry how many? Just 8. So we have added 10. Remember what? Remember 3. 13 minus 10, remember 3. So the last shell, 1, 2, 3. Since we have 3 valence electrons at the atomic shell, it is what? It is plus 3. Remember what I told you. If you have 1, plus 1. If you have 2, plus 2. If you have 3, plus 3. Okay, so aluminium is 3. So 3
multiply by 2, so that's 3 times 2, okay, plus, you see sulfur. 3 is going to multiply everything in this bracket, both sulfur and oxygen, okay. So 3 now, we multiply everything, both sulfur and oxygen. So 3 times S will give you 3S, okay, 3S, because you're looking for S, so 2 times S, 3S. Then oxygen is minus 2, okay. Oxygen is minus 2. Remember what we did in the last example. So minus 2 times 4, because 4 is in the front of oxygen. So minus 2 times 4 times 3. Remember 3 is multiply everything in the bracket. So minus 2 times 4 times 3. Yeah. So it's a neutral atom. So what do we do? Since it's a neutral atom, we equal it to 0. We equal it to 0. Okay, so let's multiply through. 3 times 2 will give you 6. Okay, so plus our 3x, so bring down our 3s, which is 3s, minus 2 times 4 times 3, minus 2 times 4 times 3. So can you guess what the answer will be? So let's calculate. 2 times minus 2 times 4 will give you 8. 8 times 3 will give you minus 24, so equal it to 0. So now we have to collect our like terms. Remember, 6 cannot plus 3s, okay, it's not a like term, so we collect our like terms. So our like terms will be number to number. So 6 minus 24 plus 3s equals to 0. So let's do our calculation. 6 minus 24, 6 minus 64, can you guess the answer? 6 minus 24 will give us minus 18 plus 3s, okay. Sorry for the 36 I wrote, is 3s. So minus 18 plus 3s equal to 0. So what do? We collect like terms, okay, because minus 18 cannot plus 3s, they are not like terms, so the like terms is 0. So minus 18 cross over the equal to sign, meeting 0, so it's gonna be 3s equals to 0 plus 18, okay. So I keep on writing 36, sorry, that's 3s. So now 3s equals to 0 plus 18 will give us 18. So what do? We divide both sides by the coefficient of 3s. So the coefficient of 3s is 3. So divide both sides by 3. Okay, so 3, 3. 3 going to 3 give you 1. 3 going to 18. S equals to what? S equals to 6. So 6 is our answer. Our S is 6. So you can see it's a very simple calculation. Okay, let's go to number 2. Give the Iupac nomenclature. Okay, give the Iupac nomenclature. So can you guess the Iupac nomenclature? Okay, let's go there. So the Iupac nomenclature is aluminium. Okay, aluminium. Ignore the 3 outside the black bracket. You are not going to include it in the Iupac nomenclature. So you ignore the 2 at the aluminium. Okay, so it's going to be aluminium tetraoxo sulfate 6. Okay, aluminium tetraoxo sulfate 6. Very simple. So let's write it down. Aluminium tetraoxo sulfate 6. That is the answer. Very simple. 4 is tetra. Remember, 4 is tetra, 3 is tetra. So the 4 there is the tetra. Okay.
Calculate.
So that is just answer. Let's go to the next question.
Oxidation number of NO3 minus is the Iupac nomenclature. Okay, very simple. So let's calculate the oxidation number of NO3. We'll calculate the oxidation number of nitrogen in NO3 minus. Okay, this is the correct question. So let's calculate the oxidation number of nitrogen in NO3 minus. Okay, let's do solution. Solution. We are looking for nitrogen, so just write it in capital letter.
Okay, so the oxidation number of oxygen is minus 2, then times 3. Okay, so equal it to the charge. Equal it to the charge and not 0 because it's not a neutral atom. So equal it to minus 1. The charge is minus 1. Okay, so that is just it. If it's not a neutral atom, you equal it to the charge, and the charge is minus 1. So equal it to minus 1. So let's go. N minus 2 times 3. Minus 2 times 3 will give you 6, equal to minus 1. Then you collect like terms. Okay, write N minus 1 plus 6, because minus 6 cross over the quarter side will give you plus 6. So minus 1 plus 6 will give you N equals to what? 5 plus 5. So very simple, and that is the answer. Let's look at question number 2. Give the Iupac nomenclature. Okay, so it's a very simple thing to do. So the Iupac nomenclature is very simple. As you can see, you have 3 is tri, oxygen is oxo, so trioxo nitrate 5. Okay, that's the answer. That is it. So let's write it here. Trioxo nitrate 5. The 5 will be in Roman numeral. Trioxo nitrate 5. Trioxo nitrate 5 is the answer. Okay, so very simple. Please subscribe to the YouTube channel. Thank you.